everyone. We're on to our 2x3 design. So we have our data. Look at how it's entered, right? Each participant, right, is in one level of one IV, meditation, yes or no, and one level of another IV. Amount of coffee intake that I force them to drink in the lab, 1, 5, and 10. Happiness is 5. We're just going to see here. We want to test 3 things. Does meditation impact happiness? Does coffee intake impact happiness? And do meditation and coffee intake work together to impact happiness in some unique special way, i.e. are the slopes different? All right, so I got the data here. I got my design set up. Let me make sure all the things are labeled correctly. Coffee intake is nominal, meditation is nominal, and so forth. Let me get rid of all my old analyses. And now we're starting with a blank slate. I'm going to copy and paste the data into the file. Boom. 1 row per participant. I don't actually need this. I'm not going to actually enter that, but I'm just saying this is participant 1, 2, 3, and 4. You have 1 column of IV1, 1 column that tells them what condition they are in IV2, and 1 DV. This is a 2x3 between subjects design. So analysis, ANOVA. We are going to do the ANOVA command. I'm going to hide some things here. My fixed factors of meditation and coffee intake. My DV is happiness. I'm going to use partial eta squared. It's the better one to use. If you look at between subjects, one-way ANOVA, partial and eta squared are the same, but you don't have to worry about that. It still means the same thing. Percentage of relationship that the effect causes in the DV. This is a true experiment, so I can use the word cause. We're going to have to do some extra stuff here. We could reach out and do the partial eta squared, 90% confidence interval using our tool, but we're not going to have to. So right here, when I just look at this ANOVA, we have a significant effect of meditation. We have a significant effect of coffee intake, and we have a significant interaction. We can see that, but I like to break it down one item at a time. So let's look at the meditation effect, just the image of it. So I want to see the plot. Meditation makes you happier. We can see that down here. So now I'm seeing that, okay, meditation makes you happier. I should probably look at the questions. The first question is, which mean is larger? For main effect 1 with the 2-level IV, meditation has more happiness than no meditation. So, I know that. That's cool. We can see that. Is this a significant difference? Yes, it is. What is your best estimate of the population mean difference? Well, we actually don't have that yet because we have to run the post hoc test. Now, we don't have to because there's only 2 conditions. But why am I making you do it? Because the 95% confidence interval, okay? And the effect size. So you're like, wait, what do? I have, the main effect of meditation. Yes, you do. But you're like, oh, I got my partial eta squared, which you do. But you know what's better? Cohen's d. Whenever you can get a Cohen's d, you use it. It's nice and easy to get right here. And I made some choices when I taught this class that made sure we had confidence intervals, but also considered how easy they were to get. These are actually pretty difficult to get for some of the other tests and so forth, but it doesn't matter. We have a two mean effect. Cohen's d makes sense, and 95% confidence interval of Cohen's d makes sense. So what is your best estimate of the population mean difference? 1.367 is a large effect, and 4.791 is a large effect. I predicted meditation would lead to happiness. If I had a negative effect here, I could reorder the conditions in my variable like I showed you in a previous video. Make sure you go through all the videos since I'm going through them for you, okay? But that's large to large, which I could write just large, okay? So it's a large effect, right? Write your statistical sentence for this main effect and the headline for this main effect. All right, so the statistical sentence is F with 1 and 12 degrees of freedom. We can't really see, so I'm gonna get rid of that and make sure we can see. So we're looking at this main effect of meditation that is 1 and 12 degrees of freedom. 1, 12. I'm sorry, 1, 12 equals my actual F statistic, 42.67. P-value, P is less than 0.001, comma like this. I'm going to write my Cohen's D equals 3.079. See, I'm pulling that out right there. 3.079 with my 95% confidence interval of 1.37 and 4.79. All right. I'm going to leave that. Let me see here. Font. I want to find italic. Okay, so what needs to be italicized? F needs to be italicized. So does P. So does D. And that is it. I want to make sure. Oh, I made one mistake here. 3.08. Everything's to the second decimal. Everything that needs a 0 in front of it has it. That's how I write that headline for this main effect. Meditation improves happiness. You could say, relative to no meditation, but to me that seems a little redundant. I don't want you worrying about the rules. I want you able to interpret your results. I want you able to think about this in a logical manner. But we have just finished main effect number 1. So that's all cool. What I'm going to do is just take things out of all of this, just so we can look at what we do have here. Okay, so now we got the 3-level main effect, right? So this is your 3-level. We can see that 10 cups of coffee improves happiness relative to 5 and 1. So now we're just looking at the effect of coffee on happiness. Looks like drinking coffee improves happiness. I made up the data, so don't take it too seriously. All right. So I'm seeing that, and I'm like, okay, there's, here's the results I'm looking at. So list your means from smallest to largest. 1, less than 5, less than 10. Is the ANOVA significant? Yes, it is. All you need to do is write yes. What is your best estimate of the population effect size for the omnibus effect in words? Now this one, for the omnibus effect, for the effect of coffee intake, right? I can't just happily put my 95% confidence interval of Cohen's D in there because I don't have one. I have 3 means. I'm going to have a whole bunch of different Cohen's D's and so forth. So I have to calculate the 95% confidence interval, or the 90% confidence interval for between subjects F statistic. Well, we're just going to use my calculator from earlier. All right, the F statistic for the main effect of coffee is 8.44. The degrees of freedom is 2. For the degrees of freedom 1 is the degrees of freedom for coffee. Degrees of freedom 2 is the degrees of freedom residuals, which is error, right? I haven't mentioned this in the videos in a while, but that F statistic says that the size of our effect has 8.44 times is the effect of coffee on happiness is 8 times the size of the effect of our error, right? Because remember, F is the variance of your effect divided by the variance of error. Like, I haven't even shown you this in a while either because we don't need it, but it's like sum squares divided by 1 equals, mean squared. So sum squares divided by degrees of freedom equals variance, right? Sum squares divided by degrees of freedom equals variance. Sum squares divided by degrees of freedom equals variance. These are variance of our three effects, and this is the variance of our error. And if we look at this right here, and I was looking at sum squares there earlier, so I need to fix that, but I'm not redoing the video. My F statistic here is 12.67. Hopefully I didn't make a mistake like that on another one. We'll worry about that when we have to, okay? But that's saying that the variance that's due to my effect of coffee is 12.67 times greater than the variance that's due to error. Signal over noise, my signal is 12.67 times the size of my noise. Now I need to know sample size, so I'm just going to see if there's any way I can lazily do this without counting, even though I know it's 15, I'm pretty sure, but we can see this. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17. It's 18, so that's cool. 12, 13, 14, 15, 16, 17 total degrees of freedom. 12, 13, 14, 15, 16, 17 is n minus 1, 18. So I'm glad I did that calculation. 18. Oh, degrees of freedom 12 and 18 goes down here. All right, that looks good to me. Click run. Pull this up. I'm just gonna go ahead and copy it over since I'm dealing with a lot of different screens right now. So what is your best estimate of the population effect size for the omnibus effect in words? Right, it is 0.25 to 0.74, 0.25 to 0.74. So we'll come back and talk about what that means in a second. We'll just put it here, 0.25 to 0.74. In words, these are both large, so large and large. The population effect size for the omnibus effect, for the main effect of coffee on happiness, is a large effect. We know that that omnibus effect is large. All right. So now I'm going to go back to Jamovi real quick. Just answer the questions. Write your statistical sentence for this main effect. That one's pretty easy. F with 2 and 12 degrees of freedom. F with 2 and 12 degrees of freedom. 2, the degrees of freedom for the main effect of coffee, and 12 residuals, which is another way to say error, the main effect of error, equals, I will look in the right place this time, and hopefully I didn't mess this up on previous videos, but 12.667. If I mess it up, I will deal with that. P equals 0.001. That's from right here. Okay. And my eta squared. You could use normal n if you have to. I'm not gonna judge. If you go to publish, I'll make you put in that eta squared symbol. Eta squared partial equals 0.68 with a 95% confidence interval, or a 90% confidence interval between 0.25 and 0.74. All right, what needs to be, I'm going to subscript partial here. You can do that in your programs as well. I'm going to superscript the 2. Perfect. Italicize. And italicize the F and the P as well. All right, that's looking good. I do want to check something because I think I might have put the variance in instead of the F ratio. So I'm just going to double check my work, and that's just always good. Yep, Nope, we're good. Okay. So, everything here, this is telling me this is a significant effect that is a large effect in the population. What is the main effect of coffee on happiness? We know there's some difference. If we look at the means, we can see that it looks like drinking more coffee leads to more happiness, right? But we still have to run our post hoc tests to examine this. So now I'm just going to run my post hoc tests for coffee and fill out this chart, right? I might. Okay, so you can see how the negative signs are all over the place. I'm going to go back in, show you how to do this. Coffee, right? I got 1 cup first. I'm pushing it down. 10 cups, I'm pushing up. 10, 5, 1. And you'll see, look, all that beautiful stuff happens. Every single result met my prediction that more coffee is more happiness. So my Cohen's D's should all be positive. They are. So that's good. Let's see what we got here. We got first mean is 10 cup. Second mean is 5 cup. The T statistic is whatever our T is, which is 3.00. Beautiful. 0.028. Star that. Cohen's D, 1.73. That's large. That's my sample Cohen's D. My population's Cohen's D is between 0.26 and 3.2, so that's between small and large, but 0.26. I want you to know I would never take off for not putting the 0. It's just not worth a point, in my opinion. 0.21. There's so much you got to worry about that it's not worth worrying about. But that's small to large. So I know that difference, 10 versus 5, is between a small to large difference in the population. 10 versus 1, that's going to be better. We know that. We can see the data there. 10 cup versus 1 cup. That T statistic is 5.00. P-value is less than 0.001. Cohen's D is 2.89. 95% confidence interval of that Cohen's D. That's the second one. All I'm doing is looking at this line, getting that information over there. I should have allowed you to copy and paste it, tell you the truth. Just copied and pasted the right things over there, but there's so much that we don't use. 1.08 to 4.6884. Small is 0.2, medium is 0.5, large is 0.8 or larger. Well, 1.09 is large, and 4.68 is also large. So that is a too large effect. Finally, we got 5 versus 1 cup here. 5 cup, 1 cup. The T value is 2. I love when my fake data works out so perfectly. My P value is non-significant, 0.16. I didn't star the previous one, but that one's not starred. The starring thing is just to give you, it's just what we do to say, hey, this is significant. The Cohen's D is 1.16. The 95% confidence interval of Cohen's D is from negative small to positive large, negative 0.20 to 2.51. I'm sorry, I always do that. 2.51, so that's negative small to positive large, negative small to large. I don't put the positive sign on the large because you would never do that. If you don't see a sign, assume it's positive large. Okay, so the headline for this main effect is that drinking 10 cups of coffee makes you happier than drinking 1 or 5. 5 cups of coffee than 1 or 5. However, drinking 1 or 5 cups is essentially the same. I mean, if we really want to state this, it's like drinking 10 cups of coffee makes you happier than drinking 1 or 5. We don't know. Well, actually, no, essentially the same is not true. I broke my own rule. However, drinking 1 or 5 cups, we know nothing. Okay. But we do know that drinking 10 cups of coffee makes you happier than drinking 1 or 5. However, drinking 1 or 5, we know nothing about its impact on happiness. I'm not writing it all out because it's just, it's just a lot there, and I'm super lenient on those. All right. So now we got our second main effect handled, and it was a lot. Every one of these takes a little bit of time, right? We're at the 20-minute mark on this analysis. And so, it's just what it is. Finally, we get to our interaction. So I'm going to put the interaction in such a way. Oh, that's not what I meant to do. I'm going to take these out of the postdocs there. We're going to leave those postdocs for later. But I want to create the graph with 3 lines because I'm teaching you that an interaction is a test of line slopes. And I want you to see the 3 line slopes are being tested. For me, when you do it this way, it becomes 4 line slopes that are being tested. And so this is just a simpler way to present it that will allow us to understand which slopes are different. But let's just look at this. 10 cups of coffee, right? It doesn't matter if you meditate. If you drink 10 cups of coffee, meditation has no impact on your happiness, right? There's no impact. Like there's no improvement or decrement by meditating. If you drink 1 cup, you show meditation drastically improves happiness. And if you drink 5, meditation helps happiness out. So we can see that these are different slopes. If you were on skis, you wouldn't go very fast down this slope. You wouldn't move at all, actually. You go super fast down the 1 cup slope and pretty fast down the 5 cup slope. Interactions are just tests of slope. So we see this. Let's start answering our questions here. Draw your interaction the 3 slopes way. Draw this out. Copy and paste it. I don't care. Describe each of your slopes. This is the interesting piece. Participants who drank 10 cups of coffee showed no change in happiness across the meditation conditions. Right there, I'm just being super sort of slick there. I'm just saying, hey, I'm just describing this line. Meditation did not impact happiness when you drank 10 cups of coffee. You could have wrote that as well. Okay. Participants who drank 5 cups of coffee showed an increase in happiness when meditating. It's okay to have some implied things, right? Versus when not meditating. It would be very weird for a headline to say both, right? Right? It's just kind of implied. The English language can do that to you, right? Participants. I'll fix that wording there. And then participants who drank 1 cup of coffee showed an increase in happiness when meditating. All I did was describe these 3 lines. You could put the but here, right? Like Dr. Miller taught the but, right? These 2 slopes are essentially the same. They look very similar. Like they're not exactly the same, but you can tell they're both strongly negative. And this slope up here is a flat line. That's all an interaction is. Okay. So now we keep going. Is the ANOVA effect significant? Yes. What's your best estimate of the ANOVA effect's population effect size? So this one's going to require me to go out and do this again. The good thing is though, is that this has 2 and 12 degrees of freedom with an F of 12. And you can see that the partial eta squared is exactly the same. So I'm not going to redo everything I did before. I'm just going to steal my partial eta squared for my previous main effect. There we go. Everything is the same. That's a large effect in the population. So large and large. Write your statistical effect for this interaction. This is where you put everything together. Well, the beauty of it with this specific data set is I don't have to rewrite anything because I have it from the previous example. So my statistical sentence for this interaction is the same statistical sentence as my main effect, because if you look, all the numbers are the same. So I'm just being a little lazy. You don't want to watch this video and see everything, right? But that's just a special case with this specific data set. Boom. All right. Run your post hoc test, but only look at the 3 t-tests that examine the line slope. I think that's really important here. So now when we go in, we throw our interaction effect in for the post hocs, right? Like these ones, I don't worry about the sign. Like, you know, I don't really have a prediction here. I'm just like trying to figure out, well, is this a significant difference? We know it's not. We can look at that one and see it. But I want to take 10 cup with no meditation versus 10 cup with meditation. So 10 cup with meditation, right? Versus 5 cups with meditation. I don't want that one. 10 cup with meditation versus 1 cup with meditation. 10 cup with meditation versus 10 cup without. That is negative 4.13 times 10 to the negative 16. So that's like a 15 zeros, and then your 4 comes. So that's basically 0. The t value is also basically 0. Right? That's your mean difference. That's your t value. You have to move it a little bit. You can see that little bar's getting in my way. So we got this one right there. The mean difference is 0. The t is basically 0. The p is 1. The Cohen's d is 0. And the upper and lower is between negative large and positive large. So we can see all of that right here. So that's my first one. The mean one is 10 cup with meditation versus 10 cup without. The t statistic is essentially 0.00. The p value is 1. The Cohen's d is 0, I believe. We can do better than believing here. Can pull it over so we can see it. We're right here. That's a 0 Cohen's d and negative 1.78 and positive 1.78. So 0, negative 1.78 and positive 1.78. You know nothing there. That is negative large to positive large. All right. So it would be nice. What would have been nice if that would have been negative less than small to positive small, but that's not what we found. All right. Our next post hoc analysis should only examine, let's look at the 5 cup with meditation and the 5 cup without. So this is 5 cup with meditation versus 1 cup with meditation. 5 cup with meditation versus 10 cup without. 5 cup with meditation versus 5 cup without. It just, like, you just gotta kind of fill in the dots here, right? So this is yes, 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 meditation, yes, 5 cup, yes, 5 cup, yes, 5 cup, no, 5 cup. The mean difference is 2. The t statistic is 4.24. The p-value is 0.011. The Cohen's d is 3.46. The 95 CI of Cohen's d, you gotta just stay highlight. Get a highlighter out on yours or something. It won't let me highlight it. Oh, and I just made a headache for myself, but that's fine. I'm right here, 1.11 to 5.82. 1.11 to 5.82. This is a large to large effect. So the difference between 5 cup with meditation and 10 cup, and 5 cup without is a large effect. Now we got 1 cup with meditation and 1 cup without. That T statistic, yes, so we're down here. Yes with 1 cup, right? Yes with 1 cup, no 5 cup. Yes with 1 cup, no 1 cup. That's the one I want right there. That T is 7.07. Right? You can see that yes 1 cup, no 1 cup. P-value less than 0.001. My Cohen's D is 5.77. 95% confidence interval of Cohen's D is 2.65 to 8.8. It was going to be 8.9, but you round up to 9.0. Always 2 decimal places, and that's large to large. So those are really postdocs that aren't for me. Like, other people will ask those. Other people will be curious about that. I definitely want it on the task, just so you know. But all I'm doing here is saying, hey, these two means are not significantly different. These two are, and these two are. Just to sort of add to the slopes. I really think you should be able to just describe your interaction with the slopes. But because some folks on the faculty will ask you for this, I got to teach it to you, okay? So then, what does that mean? Write your headline for this interaction. Meditation improves happiness when you drink 5 or 1 cups of coffee, but has and so I'm torn right here. Like, here's what I want to say, but has no effect when we drink 10 cups. You could say, right, has an unknown effect when you drink 10 cups. But ultimately, like, I get it, right? Ultimately, what's important here is that you see that this slope is different than this slope is different than this slope. I think these postdoc tests don't really matter, so I'm going to go with this right here, just in case somebody asks you, right? But I only choose these t-tests because interaction is just a test of line slope. That was a lot, but we did it, right? I will accept a lot of answers there. What are we into this? 33 minutes into this ANOVA. It took me 33 minutes to do this ANOVA. There's a lot in this ANOVA, but now we are done.